Hello, my name is Robin Mitchell, and today Electropages is here at Embedded World, Nuremberg, and today I'm at the Harwin post and I'm joined by Sam.
Hi Robin.
Thanks for having me. So today you wanted to go through with your new BBI range, so could you just start by introducing us to what that is and how it works?
Yeah, so the BBI range is one of Harwin's new 3 product families. Last November we differentiated our product families because we've got a very diverse portfolio.
Yeah.
So we separated BBI, which is board-to-board interconnect, to HRI, which is high reliability interconnect, and EasyI, which is all of our EMC type products.
EMC?
EMC, yeah. That's BBI, but it's designed to the connectors, their industrial use, embedded applications, high reliability, high volume, small pitch, all sorts of those applications.
So in front of us we've got 2 small boards. Is this an example of the BBI range?
Yeah, so that's actually our Archer Point 5 series, so that launched last year. It's the baby brother, effectively, to the Archer Point 8 series, which we launched a few months earlier.
Right.
Both of the series are capable of carrying high speeds of data transfer. So the Point 8 is actually capable of carrying 12 gigahertz or 24 gigabits per second. And both families are applicable to USB 3.2, HDMI 2.0, and SATA 3 industry standards of data transfer.
And so this one here would also be 12, is it 12 gigabits per second?
So the 0.5 is 8 gigahertz and 15 gigabits per second.
So this one here would be 15 gigabits?
Yes, yeah.
So that's quite fast for a small connector.
Yeah. So the speeds that we've got out there are performing really well in comparison to seeing what else is out there in the market as well.
So you've got these board-to-board interconnects, but why is it that an engineer would need to use that in those applications that you listed? Why would they not have everything on one board?
So typically it's to transfer the signal from one board to another. So inside embedded systems, inside Industry 4.0. So yeah, when you're transferring one signal from one circuit down to another circuit, inside these systems where you need to relay that signal very quickly.
So you might have like let's say like a modem that might be attached externally, so you can get the high speed from that device, but you can sort of split up your design into different boards. So it's kind of easy to basically handle.
Yeah, that's it. And you may also have stackable boards within a circuit. So yeah, transferring from one board to another, and then again you might go another layer up. There's varying different applications that they can be used for, connecting one board to another board.
Can I try and connect those two together?
Absolutely.
So what actually locks it together? Because it doesn't look like.
So these ones don't actually have locking features. So the Archer Point 8 and Point 5 are unlatched or unlocked connectors.
Yeah, but that's solid though.
Yeah, so they are actually tested to vibration as well.
Yeah, so you can see on the camera that you can see that even though I put them together, they're not exactly. You can see how I need to do a bit of force to actually bring them apart. So they're still quite solid, aren't they?
Yeah.
Yeah.
Yeah, the Archer Control series within the range as well, that's actually tested. We've got vibration data on that one, and that's also unlatched. So similar principle, but slightly larger pitch.
And that's what I was going to ask, because you also said you've got the high reliability range, haven't you? Is that the...
No, so the Archer Control is still within our BBI series. Our HRI series is Gecko, Kona, Datamate. So yeah, some severe levels of vibration, shock.
And so high reliability might be found in maybe things like automotive applications?
Yeah, automotive, UAVs, other space applications as well. Medical, so all of those kind of industries.
And so do those connectors have like locking mechanisms where to keep them together? So
we've got varying levels of locking. So we've got latches and we've got screw locks or jack screws depending on the family.
And do you have like environmental sealing as well on those?
So we don't actually have an IP sealed connector at the moment. We do have back shells to seal for EMC. And we have that across the series as well.
I suppose, to be fair, you wouldn't really need IP sealing because this is like internal to the circuit itself. It's not like it's not going to the outside world.
That's it. Yeah,
so you don't really need it. So
that's it. Yeah, most of the products are within the box, within the enclosure, or we're connecting from outside of the box to inside the box as well.
Now, on the side here, we've also got what looks like some shields for EMC. Could you give us a bit of information on what this is?
Yeah, so this is part of our EasyI family. It's comprised of, as you can see, their shield cans. We have shield clips with those. Shield clips and cans combination is an industry solution, really, to avoid soldering the cans direct to the PCB.
Yeah.
So customers can save huge amounts of time by purchasing and auto-assembling the clips and then manually assembling cans on top.
And I suppose if you have cans that are removable, it can help with replacing hardware as well. So if you had a shield big enough, you could have maybe a power module removable, so you can upgrade it with a different one, but then pop the shield back on top.
That's it, yeah. It's reusable, and most of the clips are rated to 25 cycles.
Yeah.
So yeah, between 10 and 25 cycles, you can reuse that clip and can combination.
That's a good question. Going back to these type of BBI connectors, what kind of mating cycles can we expect out of these types of connectors?
So they vary. I won't commit to a figure off the top of my head because just in case I state the wrong one. But we're looking over 100 on the full range,
100?
at least. Yeah.
But no commitment.
No commitment onto the exact figure.
Okay, you don't expect does this get disconnected 100 times?
No, that's it. It's different to the HRI range where you might be plugging inside and outside of the box. These are embedded into the system. So once it's there and once it's together, it's unlikely you'll be unplugging it again.
Now, out of all the applications that you know that your connectors have been used in, what would you say was the most interesting one?
There's probably too many to speak of, to be honest. Yeah.
Looking at satellite right there behind
us. That's it. The Gecko series in particular, the Gecko MC, actually used a lot in satellites, in drones as well. So yeah, that's really interesting from that perspective. To be honest, there's a lot of different things that I find interesting about where the products are used.
Yeah.
People also use them for things that you wouldn't necessarily expect or what we haven't designed them for.
Yeah.
And that's always interesting to see. So yeah, a grounding clip here, for example, might be used to mount to an edge of a casing, just to be grounding on the circuit.
Yeah.
But people are using those for so many different things, and it's just interesting to see what the products are being used for.
Fantastic. So, in terms of the future, what is it that Harwin's looking to do down the road?
So since we actually performed the rebrand last November, it's enabled us to focus our energy.
Rebrand?
Yeah, so rebranding and launching the 3 different product pillars.
Oh, right.
So the EasyEye, the HRI and the BBI. That was a big launch at Electronica last November.
Oh, that was a good one, wasn't it?
Yeah, it was a great show, and this one's following suit as well. It's really good to just get out there and talk to engineers, find out where people are using the products, what different scenarios people have going on where we can try and develop something new as well.
Yeah.
Since then it's enabled us to focus our energy on different product development in each family, as well as the manufacturing in each family and the marketing in each family. With BBI in particular, we're listening to the market and we're developing floating connectors. So that is where the connectors will self-align during mating.
Oh, that's pretty cool.
Yeah, so you can afford to have some misalignment between the boards, and that's really beneficial when you're using the connectors to actually align and fix the 2 circuits together, rather than having terminal pins or.
And I suppose that helps with reliability, doesn't it, as well? Because you're less likely to damage the parts. Because if your pins are misaligned, you can't bend them and stuff, I suppose.
Yeah, that's it. It avoids any damage and it keeps that signal integrity throughout the circuit, rather than mating and being offset and not getting that.
Now, if an engineer watching this video wants to get in contact with Harwin to look at some new connectors for their products, what would you recommend?
So visit our website. We have all the contact information there. We have a huge range of information readily available as well. Free CAD downloads, free sampling, and free technical support as well. So yeah, get in touch and we'll be happy to help.
Well, thank you ever so much for taking the time to see us today. Thank you very much.
Thank you.